Dear student, in previous lecture, we learned about how to do programming using Tinkercad application. Now in this particular lecture, we are going to perform some more experiments. Our second experiment will be same as blinking LED experiment, but it will be different than that because here we are going to learn the pattern generation using LEDs. So let's start. First of all, you need to go to tinkercad.com and then there you need to log in. So open your Tinkercad account, then go to designs and then click on create a circuit. The simulation window will appear on your screen. Now we need to select the components. We have to prepare the circuit and then accordingly we need to write the code for that circuit. First of all, we need to take one Arduino, type Arduino. You will get Arduino Uno. Bring the Arduino on your workspace like this. You can minimize the size of the Arduino so that you will get the full screen. Now next, as we had discussed previously, that it is better way to use the breadboard for making the circuit. So we are going to use the breadboard. For that, I will simply take a breadboard and this time I'm going to use a long breadboard in place of using a mini breadboard. Let me keep the breadboard over here and accordingly I will adjust my Arduino board somewhere like here. If you want, you can give the name to your devices or it is not required, not compulsory. Now we have to generate the pattern, and to do that, here I'm going to use 8 different LEDs. So I'm going to use 8 different LEDs and we are trying to generate different patterns using those 8 LEDs. So first of all, we need to create the circuit for those 8 LEDs. Let's start the process now, and we know that we need to use the LED. So simply type LED, find the LED, drag and drop the LED on your breadboard. So this is my first LED. Similarly, I'll take the second LED, then the third LED, next LED, similarly, I'm going to put all those LEDs on my breadboard. It is not necessary that we are going to use only 8 LEDs, but if you want, you can increase the number of LEDs as per your choice. So I am taking more LEDs so that when I'll do the program and when it will appear, we can make different type of the patterns using these LEDs. So here you can see I have used these many number of LEDs and now I'm going to program. If I'll click on LEDs, it will show the name and accordingly I had used total 11 LEDs here. One more I will add so that it will be 12. So these many LEDs I have used. Now I have to use the resistor. So type resistor. You will find the resistor. Place the resistor like this. Change the value of the resistor to 220 ohms in place of kilo ohms. And then I want to copy this resistor. Okay. So there is an option of copy. So I'll click on copy and then after I'll place that somewhere. Paste. So that I need not to change the value every time for all the register. Again paste. So this will become very easy for me. Otherwise, again and again, I need to take the value, change the value of the resistor. In place of doing that, simple, I will copy and paste the components and automatically it is increasing the name of the resistance also, but the value remains the same. So it is creating my job easy. So in this way, I can drag and drop all the resistances. Yeah. So 12 registers I have connected, 12 LEDs I have taken. Now I need to apply ground and I need to apply the VC's power. So one terminal ground I will take here. This is my ground of Arduino. So I'll connect this like this and I will connect this at the bottom one. So it is clear that the bottom in all the pins of the last row, the ground is connected, and we need to connect the second part of our LED with the ground. So I will connect like this. For all the LEDs, I have to do the same thing. I'm connecting all LEDs one by one. Similarly, you can also create your circuit. You need to remember that you need to connect at the bottom row, not at the second last row. Otherwise, the connection will be wrong. Sorry, here I have made mistake. Let me select that and delete. So in this way, we will connect all 12 LEDs. Yeah. So we have created our circuit. Half the part is done, but half is still remaining because we need to now connect the anode terminal with different pins, and that we need to remember also. So pin, this is my LED 1. You can see LED 1. I will start from LED 1 so that it will be easy while programming. So the second terminal of the resistor, I will connect to pin number 1. Now it is going to be very complex circuit. So I am using the path like this so that I will not have much confusion in my circuit. It is connected to D1, means pin number 1. The second LED I need to connect. So from here I can connect it to pin number 2. In this way I will prepare and connect the entire circuitry. You can see how I am doing. Just click as and where you want so that you can turn the wires, the cables. One by one, I am doing it. So 4 I had connected. Now number 5. Whenever you are doing these type of circuitry, you are creating, that time you need to keep in mind that connect the pins which you can remember easily. Like if you have connected pin number LED number 2 to pin number 1, then it will be difficult for you to remember that. So that's why pin 1 LED to LED 1, pin 2 to LED 2, and so on. This will make your job easy. Otherwise, it is going to be very difficult and the output of your program will not be that much correct. So now I will connect it directly to pin number 9. Then, sorry, this one I need not to connect. I'll delete this. Here first to pin number 9. This one to pin number 10. This one to pin number 11, and the last one to pin number 12. Wow, circuit is too much complex for us. So I have made the entire circuitry. Now it is time to do the program. And we know that programming using the block code is quite easy. So I will now start coding. Let me start here. So we know that we have used 12 LEDs, and here also, let me start from the beginning. So I'll delete the block so that I can explain you from the beginning how to write the code once again. So forever block we have used because we want to blink the LED forever. Okay. So now we'll come to the output. We need to take one pin number at a time. So set pin number. First, I'll start with pin number 1. Okay. Pin number 1 to high. And then I need to wait for 1 second. And then I will again go set pin number 1 to high. Then we have to keep it on low. So pin number 1 to low. Then pin number, before that we need to add the wait state. Then pin number 2 to high. And then wait I'll put in between, but it is not a good thing. Then again pin number 2 to low. Again wait. Now again come pin number 3 to high. Then pin number 3 to low. Pin number 3 to low. Now moving ahead, let me show you. Till now pin number 3 is done. Let me check once how it functions. So I'll click on start simulation. Pin number 1 is glowing, 2 is glowing, 3 is glowing. So in this way, 1, 2, and 3, and it is giving me one pattern. Let us do it for all the pins. The program size will be very much big, but we want to do it. So let's stop the simulation and start writing the program. Okay. So pin number 3, I need to wait for 1 second. Then pin number 4. Pin number 4 to high. Wait for 1 second. Then pin number 4 to low. Now next pin number 5. But before that we need to add wait. So I can put wait also in this way. So now pin number 4 is done. Pin number 5 to high. Wait for 1 second. Pin number 5 to low. Then wait for 1 second. Next pin number 6. Pin number 6 to high. Wait for 1 second. Then pin number 6 to low. Wait for again 1 second. Now next pin number 7. Pin number 7 to high. Wait for 1 second. Then pin number 7 to low, then wait for 1 second. Now next pin number 8 to high, wait for 1 second. Then pin number 8 to low, then wait for 1 second. Now pin number 9 to high, wait for 1 second. Again pin number 9 to low, then wait for 1 second. Next pin number 10 to high, wait for 1 second. Pin number 10 again to low, wait for 1 second. Now only 2 pins are remaining. Pin number 11 to high, wait again for 1 second. Then pin number 11 to low, then wait for 1 second again. Next pin number 12, our last pin, to high, and then wait for 1 second. Again pin number 12 to low, and then wait for 1 second. So in this way we have created our program. Before executing the program, we need to check it once whether we have written the program correctly or not. And to do that, I will simply see how much big program we have written. So I will start from the beginning. So pin number 1 high, pin number 1 low, pin number 2 high, pin number 2 low, pin number 3 high, pin number 3 low, pin number 4 high, pin number 4 low, pin number 5 high, pin number 5 low, pin number 6 high, 6 low, 7 high, 7 low, 8 high, 8 low, 9 high, 9 low, 10 high, 10 low, 11 high, 11 low, 12 high, 12 low. Now we'll see the output for this code that we have written using block coding. I'm pressing on start simulation and see the magic, what happens. So you can see the simulation is started now, and one by one the LEDs are glowing. So you can see here after pin number 12, again the pin number 1 started glowing. So this is one pattern wherein the LEDs are glowing one by one. Now suppose, let us consider for a minute that we want the LEDs to glow continuously. It means that we want pin number 1 to glow first, then pin number 2. When pin number 1 is glowing at the same time, when the pin number 2 will glow at the same time, pin number 1 will also glow. In this way, if we want the pattern, it means first this will glow, then the second, then the third, then fourth, and when the fourth is glowing, all first four will glow together. In that way, we want the pattern to be created. So how we can generate that pattern? We need to simply use the logic in that situation. If I don't want to keep any particular LED in off condition, then all the parts where we had written wait for 1 second and keep it low, those line of blocks or those line of codes we need to remove from our coding. So if we'll do that, then continuously all your pins will start glowing one by one and will keep glowing. So let's change that. So we have idea. What we need to do is we need to remove the low part and wait 1 second part. So click here, delete block, wait, delete. Pin number 2 is high, okay. Pin, wait for 1 second. Then pin number 2 low, delete. Wait 1 second, delete. Pin number 3 low, delete. Wait 1 second, delete. Pin number 4 low, delete. Wait 1 second, delete. Pin number 5 low, delete. Wait 1 second, delete. Pin number 6 low, delete. Wait 1 second, delete. Pin number 7 low, delete. Wait 1 second, delete. Pin number 8 low, delete. Wait 1 second, delete. Pin number 9 low, delete. Wait 1 second, delete. Pin number 10 low, delete. Wait 1 second. From the codes, we need to delete all the blocks which is going to keep our LEDs in low condition. It means in off condition. So now we'll see we have only the high conditions. How our program will behave when we do like this. Let's see. Let me start the simulation. So you can see here now all the LEDs are glowing. If you want now to change the pattern, like first 4 LEDs will glow or first 2 LEDs will glow, then second 2, then the next 2, then the next 2, like that, that we can do that also using the coding. So let us do that too. So what we are going to do is we are going to glow first 2 LEDs together, then we are going to keep it off, and then the next 2 LEDs will glow in that way. So pin number 1 and pin number 2, it is difficult to delete from here. Yeah. So pin number 1 and 2 high. Wait for 1 second. Now I need to keep pin number 1 and 2 low. So set pin number 1 and set pin number 2 to low, 1 and 2 to low. Don't be confused because I am editing on the same. And then wait for 1 second. Then what I want, pin number 3 and pin number 4 to run together. And then after wait for 1 second. And then I want pin number 3 and 4 to be in off condition. So that I'll include pin number after 1 second, pin number 3 and pin number 4 to be low, 3, and then pin number 4. This I need to keep low. Then again wait for 1 second. From the control you will get that. Wait for 1 second. Now pin number 5 and 6 to be high, and then after pin number 5 and 6 to be low. So set pin number 5 and set pin number 6. So it is pin number 5 and pin number 6 to be low. Now wait for 1 second after pin number 5 and 6 to be low. Now pin number 7 and 8 to be high. 7, 8 to be high. Wait for 1 second. Then 7 and 8 to be low. So pin number 7 and pin number 8 to be low. Wait for 1 second. Then pin number 9 and 10 to be high. Wait for 1 second. Then pin number 9 and 10 to be low. So here pin number 9 and pin number 10 to be low. Then pin number 11 and 12 to be high. Then pin number 11 and 12 to be low. Pin number 11 low, and then pin number 12 also low. Wait for 1 second. Now I'll remove all this weight blocks. Yeah. So now I have written the program, and now we'll check how the output appears for this particular program. So start. So you can see from here, the pattern is generated. Now, if you don't want the lights to be off, that also you can do. If you don't want the lights to be changing, that also you can do. So this is the way how we can generate the pattern. We can do it for 4 lights, then on and off, then on and off, and similarly. This is the second experiment, and this experiment is called as the pattern generation using LED. We can create different patterns like this. Let me stop the simulation. If you want to make any changes on the circuit, then that also you can do. I hope you might have find this experiment easy. If you have any doubt, any questions, you can write on the comment box. I will answer to your question. In previous session, we have seen how to code using Arduino and Tinkercad. Now, we will learn some theoretical part of Arduino so that we can learn the Arduino programming in a better way. And in this part, we will learn about Arduino data types, variables, constants, operators, and typecasting. These are some fundamental concepts that you need to know when you are writing a program. First, we'll talk about the Arduino program structure. The first new terminology is the Arduino program called sketch. Arduino program can be divided into 3 main parts: structure, values, and functions. Software structure of Arduino consists of 2 main functions. First is called as the setup function, and the second one is called as the loop function. You can see in the sketch diagram here, the first part is void setup, wherein we can write the setup code, and the second part is called as void loop, wherein we are writing the code which we need to repeat continuously. Moving ahead, we'll now talk about the data types. A data type is a classification of data that tells the compiler how to store, manipulate, and interpret the data. For example, an integer data type can store whole numbers such as 1, 2, 3, etc. Similarly, the character data type can store single characters such as A, B, C, etc. A Boolean data type can store either true or false values. There are many data types available in Arduino, and these data types are listed here. You can see different data types available on Arduino. These are void, boolean, char, unsigned char, byte, int, unsigned int, word, long, unsigned long, short, float, double, array, string character array, and string object. These are the data types which are available in Arduino. Now we'll learn about these data types one by one. The first data type that we talked about is void. The void keyword is used only in function declarations. It indicates that the function is expected to return no information to the function from which it was called. The format of this void data type is void loop, and then the rest of the code we need to type. The next data type is the Boolean data type. The Boolean holds one of two values, true or false. Each Boolean variable occupies 1 byte of memory. You can see how we can use the Boolean data type as Boolean value is equals to false or Boolean state is equals to true. In this way, we can declare the Boolean data type. Coming to the next, the character data type. A data type that takes up 1 byte of memory that stores a character value. Character literals are written in single quotes like inside a single quote A, or for multiple characters, strings use double quotes like inside the double quote A, B, C. However, characters are stored as numbers. You can see the specific encoding in the ASCII chart. This means it is possible to do arithmetic operations on characters in which the ASCII value of the character is used. For example, A plus 1 has the value 66 since the ASCII value of the capital letter is 65. So here, if we will try to do the arithmetic operations between capital A and plus 1, then the answer of this A plus 1 is going to return us 66 because the ASCII value of the character A is 65 plus 1, so it will return us 66. So in this way, we are using the character data type, and we can do the manipulation, the arithmetic operations using the characters also. Moving further to see the next data type, that is unsigned char. The unsigned char is an unsigned data type that occupies 1 byte of memory. The unsigned character data type encodes numbers from 0 to 255. Let's consider an example. Unsigned char is equals to 121. This is the declaration of variable with type unsigned char, and to initialize it with character 5. Byte data type. A byte stores an 8-bit unsigned numbers from 0 to 255. Let's take an example of the same, that is byte small m is equals to 25. So in the declaration of the variable with the byte and initialize it with 25. The next data type is the most widely used data type, that is integer. An integer data type that can store values from minus 32768 to plus 32767. It occupies 2 bytes of memory. Let's take an example of the same. It is int, and our variable name is counter, data type name is counter. So int counter is equals to 32. The unsigned int. Unsigned integer data type that can store values from 0 to 255. The unsigned int data type is used. Unsigned integer are the same as int in the way that they stores a 2-byte value. Instead of storing negative numbers, however, they can only store positive values. Unsigned int counter is equals to 60. This is the example. Now, the next data type that we'll talk about is the word. On the Uno and other 80 mega based boards, a word stores a 16-bit unsigned number. On the Duo and Zero, it stores 32-bit of unsigned numbers. Let's take an example of the word data type. So word W is equals to 1000. Declaration of variable with type word and initialize it with 1000. The next data type, long. Long variables are extended size variables for number storage, and it stores 32-bit. Long variables are extended size variables for number storage. It can store a huge amount of the data, a huge number of the data that ranges as shown on the screen. Now we'll talk about the unsigned long data type. The unsigned long data type are extended size variables for number storage, and it stores 32-bit. It means the 4 bytes of the data. Unlike standard longs, unsigned longs will not store negative numbers. That is the limitation of this unsigned long. The next data type is the short. A short is 16-bit data type. On all Arduino boards, a short stores 16-bit value. The next data type is the float. This float data type is also widely used. The data type for floating point number is a number that has a decimal point. Floating point numbers are often used to approximate the analog and continuous values because they have greater resolution than integers. For example, float variable name is num, and that is equals to 1.352. Next is double. On the Uno and other 80 mega based boards, double precision floating point numbers occupies 4 bytes. So if you compare with float, the float stores less amount of data, whereas the double stores the 4 byte of the data. That is, the double implementation is exactly the same as the float with no gain in precision. The example, double num is equals to 45.352. Now we'll talk about the Arduino variables, why the variables are being used, and how we can use the variables for our benefit. A variable is a named location in memory that can store a value of certain data type. For example, you can create a variable named x and assign it a value of 10. You can use the variable x in your code to refer the value 10. I hope you might have understood about the variable. Let us move further and talk more about the variables and understand the variable and its naming rules. The naming conventions for the variables is variable must start with a letters, digit, and underscores to define a variable. Avoid that conflict with pre-keywords and function whenever you are declaring any variable. The variable uses camel case. It means you can use multiple words together. For example, my variable or my second variable. The third point that you need to remember whenever you are declaring any variable is it is case sensitive. So all the Arduino variables are case sensitive. If you are writing my variable all in small letters and then you are declaring another variable wherein my variable m is capital, then both are considered as two different variables. So you need to keep this thing in mind whenever you are declaring any variable. Let's see how we can declare and how you can initialize the variable. So first, whenever we want to use any variable, we need to first declare the variable. In Arduino, variables should be declared before they are used. Declare variables using the following syntax: data types, then variable name. The second point that we need to remember is after the declaration, we initialize the variable. So variable can be initialized at time or at later point. For example, age is equals to 30. So you can use it whenever you require. And the third point that we need to remember is the multiple declarations. Multiple variables of the same data type can be declared on the same line, like int, var1, var2, var3, etc. More about the variables. Basically, there are two types of variables available. The first type of the variable is called as local variables. Variables that declare inside a function or block are local variables. They can be used only by the statements that are inside that function or the block of code. Local variables are not known to function outside their own. So let us consider the example mentioned here. In this particular example, we had declared our variable inside the loop function. So the variables declared as x, y, and z can be used within this place only, within the void loop only. This variable x, y, and z cannot be used anywhere else. This is the way how we are using the local variables. Let's move further and talk about the global variables. The global variables are defined outside of all the functions, usually at the top of the program. The global variables will hold their values throughout the lifetime of your program. So you can see here in your program, we had declared the global variable before writing any function. Here, int t, s, and float c are our global variables, which we had declared before writing the void setup or the void loop function. Now, inside the void loop, again, we have declared the variables like x, y, and z. You need to remember that the variables t, s, and c can be used in any of the function. Anywhere we can use these three variables in our program, but the variables x, y, and z, because these are the local variables, we can use these variables only inside the loop function. So to understand the difference between the local variable and the global variable is the local variable is defined under some particular function and it can be used within that function only. The global variables are defined at the top, not defined under any of the function, and it can be used anywhere in your programs. That's all for the variable. Now we'll talk about the importance of variables and data types in Arduino. So variables are very, very much important because they are helping us in our program to manage the memory. They are helping us for code optimization and they are helping us for code readability. So these are the importance. Because of that, we need to learn about the variable and we need to declare the variable in our programs. Now we'll talk about the operators available in Arduino. An operator is a symbol that tells the computer to perform some specific mathematical or logical function. C language types of operators. The first operator is the arithmetic operator. The second, comparison operator, Boolean operators, bitwise operators, and compound operators. Now we'll talk about these operators one by one. To start with, the arithmetic operators. Assume a variable A holds 10 and variable B holds 20. Then we can perform various arithmetic operations like the assignment operator A is equals to B. Let me annotate so that I can explain you. So the assignment operator equals to, and here we can use A is equals to B. When we are using A is equals to B, it stores the value to the right of the equal sign in the variable to the left of the equal sign. Now the next operator is the addition operator. The symbol is plus and it adds two operands, A plus B. Now when we'll add 20 plus 10, it will give us 30. The next operator, subtraction, it subtracts the numbers. A minus B will give 10 minus 20. It will be minus 10. The multiplication operator, asterisk symbol is used to represent the same. It multiplies both the operands. A into B will give you 10 into 20, that is equals to 200. The division operator, it divides the numerator by the denominator. So B by A will give us 20 by 10 and equals to 2. Then the next and the last operator is the modulo operator. And here in modulo operator, when we write B percent A, then 20% 10, and that is going to give you 0, because when we divide 20 by 10, we are not getting any remainder. So this is all about the arithmetic operator. Moving further with the next operator, that is the comparison operator. Assume variable A holds 10 and variable B holds 20. Then there are different comparison operators available, like equal to. Earlier we used a single equal to symbol, and that was used for assignment. Now here when we use double equal to symbol, then the double equal to symbol is basically used for the purpose of giving the equal operands, like A is equals to B. Here for this example, A is 10 and B is 20, so it is not true. The second one is not equals to symbol, and if you are using this operator not equal to, then here it will be true because 10 is not equals to 20. Then less than, A is less than B, yes, it is true. Greater than, A is greater than B, it is not true because 10 is smaller and 20 is bigger. Less than or equals to, here A is less than or equals to B is true because 10 is smaller than 20. Greater than or equals to, A is greater than or equals to B is not true because 20 is greater than 10. Now the Boolean operators, again assume A hold 10 and B hold 20. Then the AND operator, we are using ampersand symbol here, called logical AND operator. If both the operands are non-zero, then the condition becomes true. So A ampersand B is true. OR operator, this is the symbol of OR operator, called logical OR operator. If any of the two operands is non-zero, then the condition becomes true. So A or 0 is true. Then the last is the NOT operator, called logical NOT operator, used to reverses the logical state of its operand. If a condition is true, then logical NOT operator will make it false. The last operator we will talk is the bitwise operator. Let's consider A is having 60 and B is having 13, 1, 3, 13. Then here we are using single symbols. So and A and B will give you 12, which is 0, 0, 0, 1, 1, 1, 0, 0. OR operator. So basically, if you will see, the bitwise operator is going to perform the bitwise operation between both the values given. Okay, so these bitwise operators are AND, OR, XOR, NOT, shift left or shift right. The last operator is the compound operator. And these compound operators are increment, for that we are using plus plus, decrement, we are using minus minus, compound addition, plus is equals to compound subtraction, minus is equals to compound multiplication, asterisk is equals to compound division, pi is equals to compound modulo, percent symbol is equals to compound bitwise, one single line, n is equals to, and compound bitwise ampersand is equals to. These are the operations that can be used in Arduino as operators. You need to learn about the operator and you need to remember all these operators and how it functions. Now, the next concept about the Arduino that we are going to talk is the type casting in Arduino. What exactly is the type casting? Type casting is a process where we are converting the type of the data types. Okay, so it is basically a type conversion. Converting one data type into other data type is called as type casting. For example, converting a float data type into an int data type is called as type conversion or type casting. Ways through which we can do the type casting. The first is called as the implicit type casting. Automatic type casting that happens when a value is promoted to a higher data type. And second is called as the explicit typecasting. Explicit typecasting is done by the programmer using the desired data type in before the value. For example, inside the bracket, we are writing int and then my float. So whatever my float data type was there, that will be converted into int data type. That's all for today. I hope you will understand. If you like this video, give the thumbs up and don't forget to subscribe my channel. Thank you.